Yeah, welcome to the threat modeling working group, CycloneDX. We were just talking, Petra, there's an OWASP project that she leads, is working on something similar. It's not quite as been a lot of thought, I believe, that has gone into the schema that she's developed. But there's still a lot of missing elements that I think are crucial. Um, has anyone taken? I posted a link in the chat. Has anyone taken a look at that by chance?
Sorry, has anyone done what?
Has anyone taken a look at this?
Looking at it, I'm not certain I know what I'm seeing.
Okay. This is maybe the wrong repo. Is this the wrong repo?
Bunch of markdown files in it.
Yeah, I think that's the wrong one. Let's see. Does she have it checked in? Oh, here it is. Yeah. This is it right here. So last time me and Petra met and we walked through the entirety of the specification, and I got some clarification on some things. But has anybody else taken a look at this yet?
It wasn't posted in that CycloneDX threat model group, right? So I was kind of waiting for that to be posted there before I had a look. I didn't know where it was, sorry. So I haven't been able to attend the last couple of meetings.
Yeah, no worries. No worries. Does everybody have the link right now then?
Yeah. What you're looking at on the screen is, yeah, I've also got that link open in my browser.
Right. Welcome, Petra.
Hi, everyone.
We were just talking about your your schema.
Okay, just in time.
Yeah, how about that? Welcome.
Thank you.
Looks, I was just mentioning that you and I had a clarifying call, several weeks ago, where, you addressed some of the questions that I had about the specifics of the schema. And it doesn't look like anybody else has actually seen it yet. So I just wanted to share with a little bit wider community here, so that they can, we're not going to do it like on this call right now, I don't think, but that way they can kind of review it before the next time that we meet.
Cool. Sounds good.
Yeah. Now you're presenting this along with some other things at Global AppSec Barcelona, correct?
Yeah. So what I'm presenting this project, which is the threat model library. The goal of the project is to accumulate a data set of threat models in a standardized format. And then, obviously for that, we need to define the format, and that's kind of where this comes in. And also the other thing is to, the goal of this is to share a lot of threat models with the community, but also increase the security of open source projects. Like, for example, if we do a threat model on some open source projects and we find some, things that they should be doing and they're not doing, that can be actioned. We can always write to the authors and things like that. So that's another thing that the community will benefit from. And the third one is that anyone can then use it to feed it to an LLM and to do some fine tuning or to do some RAG or whatever they want to do with it. But, anyone who wants to kind of get their hands on and create some models themselves, they can use this open source data set. And essentially what I want to do is I want to try and get as many threat modules as possible, various types of software from various industries, so that we cover a large area, so that we have let's say someone just started in a highly regulated company where you have like medical regulations and they want to do like a single patient record. So, you know, if we push there as some kind of example of a, you know, threat model of a single patient record, they can go there, find it as like an example. It really can help people with these examples. So that's
Yeah,
kind of what
nice.
I'm trying to achieve, and that's kind of what I'm going to present in Barcelona and the showcase.
Okay, is that also going to be, are you also presenting at Threat Model Connect as well?
No, I'm not.
Just OWASP? Okay.
Yeah.
All right. Yeah, unfortunately, I'm not going to be able to stay for Threat Model Connect this year, unfortunately.
Mm.
Hopefully I will in DC though. 'Cause I always find it valuable.
Yeah, I'm looking forward to the OWASP. There's going to be some really good topics. So
Yeah, I can't wait. I can't
yeah,
wait. So this is
yeah.
gonna be good. We just happened to have you met Chris yet? Christopher Gates?
I don't think so. No. Hi, Chris.
Don't think we have.
You mentioned
Thank you,
medical
Mr. Reed.
devices, and I'm sure his ears perked up.
No,
Okay.
I've always been interested in that area though, Steve.
You think?
Not like I wrote the book on it or anything. Yeah.
Right.
Yeah,
Okay.
there's things. So are you seeking feedback on the JSON? Is that what we're doing here? Because I'm looking through it and there's things I'm seeing missing. So
Yeah.
Okay.
There's several things that are missing. There's you know, I think it's very well thought out in general.
Oh yeah.
But yeah, you're right. There's some things missing. There's also a general lack of flexibility. You know, I think, and correct me if I'm wrong, Petra, but I think you likely favored static typing and machine readability over flexibility in the schema.
Yeah, I kind of did. Yeah.
Yeah. Okay.
Yeah. But you know, I would like to understand what you guys think it's missing, and let's see how we can potentially integrate it and maybe add some level of flexibility.
Well, one of the things is this is very much done from an end user IT's perspective, not from a developer OT perspective. So when you start factoring those things in, like data sensitivity, you talk about PHI, PII, there's no operational data there, which the PHI, yeah, we don't want to leak stuff, and there's fines and stuff that we concerned about, but operating data, that's when you kill people with any OT kind of stuff. So that needs to
Interesting.
be there. You've got impact, which is a proxy for severity. That's pretty good, but you don't have exploitability, and which is kind of interesting. You've got likelihood, which actually is something we don't really use anymore. And in fact, if you submit something with likelihood to the FDA, they will reject you for it. I've got a client yesterday that was dealing with that right now. So they came back and didn't know you couldn't use likelihood. So there's stuff like that. But I understand you're talking about a superset of all possible items, not desirable items. So yeah, I'm not saying remove likelihood. I'm just saying it's something we don't use.
Yeah. When you say we don't use it anymore, I mean, it's still used within risk matrices. So I want to see where you think, where do you say we're not using it anymore?
Right. That's what that's what I said. So sadly, the term threat model is a giant umbrella term that applies to a huge number of things, different rubrics, different audiences, different audiences to see the outcome, different people performing the threat modeling, and they all have different perspectives.
Yep.
So what a CISO at a hospital is looking for is completely different than what a developer at a medical device manufacturer is looking for, complete and with different inputs.
Yep.
So so this perspective here, looking at this is very much an IT perspective from an end user. Not an OT from a developer side. So that's why I think we need a little bit more OT developer references.
Okay.
And I realize, like I said, it's an addition, not a subtraction, to add some stuff into it. That's all.
Okay, cool. I mean, this is good. So in terms of, let's start with the data sensitivity. I have a section that says business confidential. Would operational data come? No, it's a separate one.
Right, and you actually have that covered because you've got IP. I'm assuming that means intellectual property, not internet protocol. But if that's intellectual property, that's
Yes.
business. That's business sensitivity. Ooh, we just lost our algorithm that we spent 10 years developing, right?
Yeah.
Not good.
Yeah.
But then there's operational data, which is, oh, you just told it to deliver all the insulin you have in your reservoir into the patient, and the patient just died. Bad.
Okay. Gotcha. So why don't we add something like it? Like how I need to write notes somewhere. Or are we recording this?
We are.
Yes, we are.
Awesome. So I don't need to write. I will just go back to it. So why don't we add something like operational there to cover the
Yeah.
OT?
Yeah.
Perfect. Good. And anything else that you think should be added?
Exploitability.
So I see the reason I haven't added it, and maybe let's work on this thread is like, because basically it's the way I see exploitability is like if you have exploitability, your likelihood will go up.
Can't
So
use likelihood. Can't
yeah.
use likelihood.
So you can't use likelihood in the OT world, right? That's what you're trying to say.
Right.
Okay,
Correct.
gotcha. So on that note, let's just why don't you think exploitability as in like a property of the threat, right?
Correct.
Okay, cool. Let's add that too.
It's actually exploitability has two aspects to it, which I don't know if you
Okay.
want to get to this into the roots of this here, but it has the ease of exploitability and
Yep.
the scope of exploitability. So do I have to be in front of the device to do this?
Uh-huh.
Or can I be on the same land segment or within Wi-Fi range or anywhere in the world? And
Okay.
then ease of exploit is pretty straightforward. You know,
Yeah.
can I do this with a simple URL command? Do I need an electron microscope and 3 years of research to do this, and everything in between? So you have this kind of scaled approach again.
Okay.
And you could reuse things like you've got here of none, low, medium, high, critical, you know, kind of stuff that you've done.
Okay, so we can reuse that. Okay.
You can reuse those type of ordinal scaling
Okay.
that's in there.
Okay. So let's add that too.
By the way, I'm putting it out. A huge amount of work is done in cybersecurity with ordinal scales. Okay. And more and more as everybody looks at this, you don't want to do it that way. But it's, again, we're not trying to solve all the problems of the world, just encompass how it's currently done. So
yeah, we've been we stopped doing this in CycloneDX. We actually do 0 to 1 decimals. So that way, no
nice.
matter what scale you're operating at, you can have the precision or lack thereof that you want.
Yeah. So let me tell you something about why I went with words rather than these scales. It's a very silly reason, but it's just purely based on my playing around with LLMs. So when I wanted the LLM to give me like a concrete output, like a structured output, I use a library that's called Pydantic. And I had issues with it giving me a structured output with this library Pydantic if we use numbers. So I had to resort to having something like, for example, you see the tier, the enum is, I gave it 1 and I said mission critical. So that's why I didn't put like 1 or I didn't put like 4, because I had to give it a word so that the LLM understands what that number means. So that's just a silly reason, purely because of LLMs, why I haven't used really a lot of numbers in terms of the enums. So you said that the direction that it's taking is to put everything between 0 and 1.
Yeah. It's generally referred to in a more abstract term, which is quantitative versus qualitative.
Yeah.
And quantitative is a numeric, statistically based approach. Qualitative is, it feels good. Well, unfortunately, all of us, including medical, are still doing a whole lot of, it feels good. And it's easy to do. So it is getting more and more skeptical. Now, sadly for the quantitative folks, they're all statisticians. And we're looking for a tool that we can look at and say, oh, I need to apply a score to this to know to prioritize it based upon business risk, patient risk, whatever. That's what we're looking for. statisticians are looking for something that ultimately converges to the perfect number. Now that ultimately may be over years of feedback of numeric values. And it's like, well, that's just great, but it doesn't work for us. So we're in this stuck place right now where quantitative is the correct way to go, but we don't have a good way to get us there. So everybody is sticking with qualitative at the moment. Okay.
Yeah, no, I get what you mean. I've been struggling with, trying to make sure that I have a good quantitative approach to risk management in my own company.
Yeah.
I mean, not my own, the company I work in. And yeah, like I am definitely all for converting everything to a more quantitative analysis. I'm just thinking, could we offer maybe both because of the LLM thingy requirement? I don't know. I need to go back and think how we can integrate something.
Let me pull up.
Well, I mean, I know it can be done. So, I mean, CDX Gen, for example, we actually have our own LLM, and it perfectly understands the severities between 0 and 1.
Okay. Yeah, it's not just about understanding the severities, is the structured output. Is that
This
a
is a
book?
really good book. This is a book.
Okay.
I didn't write this one. How to measure anything in cybersecurity risk.
Okay.
And the first half of the book is them trying to drive a stake through qualitative methods. So you can kind of fast forward through that and actually get into the quantitative and then realize, yeah, there's issues there too. But it does give you an idea. And so you're always looking at percentile values. You're saying, I'm 90% confident I'm going to have a 50% failure, that kind of a thing. So,
yeah. That's definitely, I want to read this book. Thank you for this.
you're
So
welcome.
I'm going to put it on my list of bedtime reading.
Because I'm not saying it's great.
Okay.
I'm just saying it's
One of
better
them.
than most of the other things. Yeah.
I'll have a look because it's something I keep like I've been creating. I even created my own risk formulary in LaTeX with like all the quantitative risk analysis formulas. So I really want to see how that compares to this. So going back to it, it's not about just them understanding it. It's more about the structured output. So, for example, if we want an LLM to create this output with a number, this is where they struggle. So they understand the output, the input. If you give this to an LLM and give it as an input, they will understand it. But if you ask it to give me, a threat model that is in this output and it's structured this way, it really struggles with giving structured output. It just actually doesn't have that. The Pydantic library doesn't have that capability. So, but obviously,
something that LLMs can do. I'll have a job tomorrow. Good.
Yeah, I mean, to be fair, it's more of a library that gives you the structured output limitation. But obviously that limitation has arose from the limitation of LLMs, kind of giving this kind of structured output in the first place. So let me go back and think on how we can try and capture both, if anything, because I think I agree with you like completely.
So why I'm on a roll here, and I'll just throw a couple more over here. Access control methods, authentication methods, data store type, access control methods. You're very IT focused here. Okay. Very IT. Access control list, role-based authentication, MAC addresses. There's lots of other. Well, maybe you want a different type. Maybe you should call it. You got authentication then. Yeah, and under authentication, there are for machine to machine. There's lots of stuff you're not talking about there. Okay.
Give me an example.
Challenge response mechanism. Okay.
Okay.
If you have a two-party authentication, in other words, you're using PKI. Okay. That's one thing. If you have a two-party Alice and Bob, you don't have that trusted third entity that you can confirm certificates off of. So instead, how do you do it? And there are what are called things like challenge response mechanisms, where you can communicate between Alice and Bob, and any eavesdropper looking at this will only see random numbers, They literally will have no idea what's going on. They never see the keys. The keys are kept private on either side, and it's a symmetric way of handling it. And yet they can authenticate, and they can both prove to each other that they have that key without ever sharing that key. So there are things like that very commonly used in machine to machine, because again, PKI is not everywhere.
Okay, let's add that. And if you have any other ones, let's add the other ones. Let's expand the list.
Okay.
Obviously, you know, I'm very much aware that this is a limited list. I already have a new version written
That's
somewhere
right.
with a longer
That's right.
list.
This is all with love. Okay. I mean this to help. Okay. I'm not being critical at all.
No,
I didn't sit down and do this huge amount of work that you did to put this together. So I'm glad you did. So,
and this is good because this is the point of view that I've never actually thought about, because I live in the tech world. So this is good stuff.
yeah. Yeah. It's quite a bit different. The Venn diagram between IT and OT is rather interesting. There's only a little bit of intersection between the two, not nearly as much as you would think. So, for instance,
Cool.
we're constantly obsessed with time in OT. Okay, what time it takes to respond to something, because you have something that is physically moving or physically being pumped or being delivered or exposed to, and you're always dealing with that. And it's like, so your code has to be able to respond to it in a deterministic time frame. And it's like, I can't just sit there and go, nope, I don't care when I get back to this. Oh, I'm going to go garbage collect now for a few hundred milliseconds. Can't do it. So there are things like denial of service attack, where in IT, that means you're shut down. Denial of service attack in OT means your data is stale. You expected to get this every 100 milliseconds. I got it at 200 milliseconds, and the industrial plant exploded. Okay. No, I'm very serious. That's the kind of stuff that happens. Yeah. It's like very small things. So perfectly valid. You can do all your integrity checks, attestation checks. But if it's just delayed, then bad things happen.
This is it's fun. Yeah, cool. Let's go on. I want to hear more about what you would add still.
No, you don't. I'm already tired of hearing myself.
I go into sponge mode whenever Chris talks.
That's why I'm right now.
You know my quote about you, Steve. When Steve talks, I just shut the fuck up, okay? Because as I said, about the time I think I understand, you know, supply chain and S-bombs and all that, then Steve talks and it's like, I'll just shut up here and listen, because no, he's forgotten more than I'll ever know about that subject.
Oh, whatever. Who's the published author here?
Yeah.
Also,
hey,
the book what's the name of the book that you published? I know it's a bit off topic, but I just.
Oh, well, I should hawk my own book, right? There you go.
Cool. Yeah, I'm just asking because, you know, I'm in the digital healthcare field as well, and it's not OT, and we're trying to stay away from medical devices.
But cowards.
Yeah, I know.
So it's a whole lot more difficult. Let me put it to you that way.
Exactly. That's why we're staying away.
When somebody comes to me with IT stuff, it's like, yeah, sure, that's easy. But if you have something challenging, and it's like devices, resource constraints are a huge one. You never think about that in IT. It's you have infinite memory, infinite time, infinite power. You don't in OT. You always have constraints on all of those. So how do you blend this in and still make the device work? And you know, you don't have things like 2FA or MFA. And, you know, an operator walks up to an infusion pump, full amount infusion pump. They have to make changes, or walk up to a drug cart. They still need to authenticate, but what happens if nobody's in the emergency room to authenticate to the drug cart, and you've got patients who are dying? That's collectively known as the break glass scenario. So you allow security to be violated to a limited extent. What is that? Access to certain drugs, maybe other things, but they can't get to Oxycontin. Or is this, no, they can get to anything, but only for the next 10 minutes. Okay. And then all of this they have guardrails placed around it. So it's, you tear down your security. It's not hard and fast. It's kind of interesting. So yeah, we have all sorts of fun things on this side of the fence.
Yeah. The we've got that other working group as well that's focusing on behaviors, and one of the things I would like to do, obviously, is tie the behavior work into the threat modeling work. Um, but in OT, it's really interesting because if you combine behaviors along with a robust representation of a threat model, you would not only be able to capture like security, like severity, but you'd be able to capture, human safety, environmental impact, disruption, um, um, economic impact, I guess. Right? You'd be able to capture a lot of different things, which could be really interesting, I think. Anyway, going back to the authentication,
Yeah.
I'm going to ask a question because I remember, and it was probably one of the 10,000 tabs I had open at one point in time, but I remember seeing a specification that was dedicated to describing how an application supports authentication and authorization. And I'm not talking about like Open API or anything like that. It could literally describe whether it's Open API or SAML or some custom thing or just JWTs passing back and forth or whatever. It was essentially a meta specification that described how the application or product supported authentication and authorization, but I cannot remember what this specification was.
Yeah. I don't know, but if you remember, it could be useful.
Yes.
It sounds like a good place to look into to make sure we got all the enums here.
Oh, it was a massive specification. So
Oh
like
yeah.
even in CycloneDX, we weren't going to do enums because we would just have, thousands of them. But we were going to because CycloneDX supports services, for example. And if we wanted to describe the authentication of those services, it would be good to support the summary information in this one spec, as well as be able to link out so that you can actually get the details from that spec. It's a similar approach that we have with the patent information that we're adding to 1.7 as well. Summary information from WIPO, and then if you want the actual machine readable stuff from the patent office itself, there's the link, right? But I cannot remember the name of that specification for the life of me. If
Okay.
somebody is watching this recording and you know it,
Tell us.
please.
Okay, well, I'll try to look for it as well. But yeah, if you find it before I do, Steve, please
Yeah,
ping me
my,
with
my
it.
Google foo has failed me. So
So let's add a non-enum in there that is just a percentile value that we're going to call a confidence interval. All right, and
Okay.
that can be applied to a lot of different other values, not enums. So as you, like I was saying, the confidence interval is I'm 90% confident that I'm going to have a 50% failure of something, okay, within a
So
time frame.
you mean,
So
okay, where do you want to add this confidence interval?
I don't know. I've gotten into the first 20% of this giant JSON file.
Okay, how about we can add it? I like that idea. I like that idea, confidence and
Interval.
confidence interval. We could add it under threats. We could add it
Okay.
under threats, like a specification that happens under a threat. Yeah. I think maybe there. Something like it can be a property of a threat. What do you reckon? Like we're 90% confident that.
Yeah, that would probably work.
Yeah. Okay. Let me have a think how on the specifics of it, but I think we
Right.
can put it there.
Yeah, if you look at that book I showed you by Hubbard on how to measure anything, you'll get beat over the head with that. So
Okay. Looking forward to it. That's what I'm ordering tonight from Amazon.
Yeah, Chris, can you put the titles of those books into the chat?
Oh yeah, good idea.
That's extra money.
Okay.
Hang on.
All right, so he can get a whole 50 cents for selling a book, right?
Hey, I'm actually making money with my book.
Are you? Congratulations.
I got a serious check from the publisher.
Nice.
It's like, well, shoot. Who knew? Okay. Yeah.
I am really curious, Chris, as you go through this, I am really interested in hearing your feedback when it comes to this specification support of data. And again, I think it comes from more of a classic threat modeling perspective and lacks any kind of OT perspective.
Sure.
So I'm really curious to see kind of your feedback on what's missing in terms of data, because I know there's stuff missing. I just don't know what it all is.
And then since you said books, I'm hyping my own here as well too. There you go.
I will forgive you.
Hey, I make $7 whole for each one of those books I sell. Huh?
Oh, you make
Don't be-
$7. Oh, okay.
$7. $7.
Okay.
Total, we make 21 and we split it between the 3 co-authors, even though Jason really doesn't do anything anymore. He's busy with another job. It's Axel and my project. So much so that we're already working on the 3rd edition.
Oh, that's fantastic.
Blimey, that's expensive on Kindle.
No shit. And the publisher makes all that money. And once we were under contractual agreement that the first 2 editions they could publish, 3rd edition, we're taking over and doing self-publishing. So it's like, nope, no more. And we're going to bring the cost down and improve our profit margin at the same time.
$144. That's yeah.
Sorry, I'm not making it. So I can't even afford the bucket of chicken from KFC here. It's like, no, no.
Maybe it's just supply and demand. I mean,
no, it's absolute greed on the part of publishers. And the publisher adds 0 value. In fact, all they do is screw things up. Okay. You see authors, thank their publisher. When I write a monthly column that I do in cybersecurity, that blog editor gets way more constructive feedback and it improves the quality of my articles. The book publisher, all they do is make mistakes. They screw stuff up left and right. So it's so tired of them.
I still have to read. I don't know. Can you see this? I still have to read this, Chris. I've cracked it open, but it is this is not a bedtime type of read. You actually have to be like in front of your computer, actually working along with it in order to like read this book.
Absolutely. Yeah, that's exactly what it is. It's a how-to book.
Yeah.
And it's there are more abstract ones if you want that are PDFs. I have one of them. It's a completely pirated PDF, so I never gave it to you. But if you want to get the theoretical one, I can give you that. This one is actually hands-on. It was really needed. And for the rest of the room, you guys don't need to know this. It's all about model-based systems engineering. And 30-second rant. Model-based systems engineering has been around for 20, 30 years in development. It's a fantastic way to approach things. In Europe, it's done way more than the United States, simply because Europe actually is educated and the United States is a bunch of idiots. And so as a result of that, we don't see it used as much as we should have, but in particular in cybersecurity, it's the holy grail and nobody's using it that way. Not in Europe, not in the United States, certainly, but it is an amazing thing. Things like threat modeling pretty much go away if you use model-based systems engineering, and it does a better job, and you can automate completely the entire process. So why? Because your model holds all information about your system. And that can be in a reaction to external devices, that can be internal subsystems and how they work together. It knows everything. So you talk about LLMs doing threat modeling, that's what it has to come out of, is a model-based systems engineering approach. But anyway, that's my rant.
Yeah. I mean, the common thing in threat modeling is that all models are wrong. And I think if and correct me if I'm wrong, Chris, because you're the expert, but in model-based systems engineering, while it is not an exact representation, there is a consistent way to represent things, no matter what it is, no matter what it is that you're representing.
Well, there's never an exact representation, is it? I mean, at the end of the day, you're
course
writing
not.
code and creating hardware, and it's therefore an approximation of what you're going to be doing. But that being said, for everything you know about it, that's all the requirements, functional and non-functional, and all of the constraints. Those are all in your model. You don't know any more about your system than that. That's it. Okay.
Yeah.
And that might be timing, that might be code, that might be, you know, data flow. You don't, I mean, everything is in there, as much as you can put into it. And you literally generate code out of your model-based systems engineering. You click the button and it writes code for you.
Yeah.
So as a result of that, it is the authority on this. There is no more knowledge you can get. What better source of information to do your threat modeling from than that?
Yeah, exactly.
And the example I always use is in a model-based systems engineering, you will say things like, these two subsystems are communicating every 100 milliseconds. They send a packet across. And as I was talking about before about stale data, what threat model ever looks at that and says, oh, wait a minute, this is good. What happens if this is delayed?
Right.
Okay. Yet you have all of that information in your model-based systems engineering, and an LLM could do that. Okay, and look at, oh, wait a minute, this is also being shared by a third device or something that goes to the front panel on this product. This could be used to inject overhead, slow down this communications, and thus wreck it. So
right. Yeah, I mean, I don't know. Threat modeling from a security perspective generally doesn't incorporate time elements all that often.
Right.
You
Like
know, because there's
never.
not, there's not a lot of CWEs. There's not a lot of, you know, weakness categories that kind of map to time-based time-based threats. The addition, I mean, in CycloneDX, we're already adding support for requirements in our threat model. I like the idea of I think they call them scenarios in Arcadia. You know, how things kind of, which are kind of is a scenario kind of like a use case.
Yeah,
Right.
exactly.
And so all of those are actually going into CycloneDX, so you can actually map, you know, the requirements or lack thereof to threats, for example. You can map use cases to threats. And, you know, it's going to get us one step closer to, I think, a little bit more mature threat modeling practice. Right, because right now it's, you know, for the most part, it's a bunch of diagrams, and, you know, you might have an attack tree or two, but it's typically a data flow diagram, and, you know, it's your typical stride or, you know.
Well, but look at what's going on in any industry where threat modeling is being done. There is going to be threat modeling fatigue. The bean counters are looking at this going, well, they're making all these pretty pictures, but how does this make me money? How does this improve things? The zealots are saying this is the way to do it, and it adds value, and it does in a limited way.
Right.
So how is this? Its life is not good. Bean counters always win. So if you look at this, how can we automate this? How can we keep the good parts, maybe even improve upon it, and make it cheaper, faster, easier to get those kind of results? So
Yeah.
that's why I'm looking at things like Arcadia. By the way, the only one in medical who cares about delayed and stale data is out of Harvard University, Dr. Julian Goldman. Great guy. He's done a tremendous amount of research and study on that. So if you ever want to look at the stuff he does, as well as interoperability, which is sort of the opposite of cybersecurity.
Got it.
So, the way that I was, you're completely right about the threat modeling fatigue, and that's something I've noticed not only in terms of, business stakeholders, but security engineers, because after you do a couple of threat models, you realize it's always kind of the same thing that you go over. And I don't know what you guys think of, I mean, it's a bit off topic from the schema, but, in terms of, could one of the solutions to this fatigue be to make sure that when we do the threat models, and that maybe doesn't apply to OT, but it probably applies to more tech. It's like, could we make sure that we do it in a differential kind of way? So we don't threat model the whole thing again. We don't go through the whole flow again, but just look at the delta of like what is new that we're building on top of what we already have, even though we risk missing
regression.
something.
Regression
Yeah.
analysis, and I mean, a lot of people are doing that, and that also stems from the fact that, at least in medical, there's a lot of iteration on a design. True start from grassroots, make a brand new medical device is kind of rare. And somebody will make a medical device, and then they go, oh, and this infusion pump now needs a toaster, and we're going to slap this toaster on it here. And so things like using regression to do that kind of stuff, regression analysis on it, to see what parts can I carry over from that last iteration into this new one and don't have to reperform, works. The problem with that is changes in use cases. Use cases matter to threat models.
Yeah,
True.
you have to capture the
True.
use cases and requirements.
Yeah,
And
that's true.
Otherwise, your threat model is useless.
so the example I always give is you have a cardiac defibrillator. You know, in the airports, you see them sitting around, right? Cardiac defibrillators. And you've got one sitting there, and it's broadcasting over Bluetooth Low Energy its battery status. Nobody cares. If it doesn't broadcast, some technician will walk by and realize it, and they'll send it, pick it up, and take it to the shop, or let's get it serviced. But nobody really cares. But if you use that same Bluetooth Low Energy interface to now talk about the settings, the sensor readings are now exposed, you could trigger a shock event off of it. Now all of a sudden you care. Couple on top of that, maybe it's a Cardassian in this country, since they're more important than the average human. That's on the ground having a defib applied to them. All of a sudden, this has spin-offs. So it matters. Use cases matter, and that's also in your model-based software engineering, systems engineering.
Well, it's one of the very first things that you start capturing in Pasta too.
Yep, absolutely. And the thing I love about, there's another system called SysML that's out of the Object Modeling Group, OMG, in the United States. It's a bunch of tools that are kind of loosely affiliated. They're fine. Arcadia stole a bunch of the ones that were useful, and they just adopted them and said, we're going to use these too. But then they turned it into a process. And one of the things I really love about it is they address it all the way to the hardware implementation. So it's not just a logical construct. It's what hardware does it wind up in? What communications is it over? How is it working? So it's actually a very cool thing. I'm sorry to have monopolized today's conversation about this. I'm losing people out of the working group here. And I'm sorry. I'm going to go get something.
No, wait, but I wanted to get more input on the schema.
No, this is all good, Chris. Thank you for it's amazing how much I learn every time you open your mouth.
I'll tell you what, Petra, I'll look through the entire JSON file and I'll write up some notes and send them to you.
Okay.
One of the things that I'm very, very interested in is, I mean, the technicalities of the spec. Yes, it needs to be flexible. It needs to account for all the different things that could potentially be threat modeled, whether it's, software, OT, processes, whatever. What I'm interested in, however, has nothing to do with the threats or, stuff like that. The end goal for me is how can we empower teams to threat modeling, in my opinion, has been too focused on threat identification uh, and not prevention. So how can we have a specification that is flexible enough, that is machine readable enough that you can use this in the prevention of possible risk? In my opinion, one of the things that why we have threat modeling fatigue, yes, it's a manual process and all this sort of thing, but it's really difficult to justify ROI for threat model, right? For risk reduction, that's easy, right? I have a defect, I close the defect, done, right? That's an easy measurement. Risk prevention is much more difficult. I mean, how do you measure the prevention of risk by changes to maybe a Word document or a diagram or, whatever? That's a much more difficult set of challenges. And I deal with those challenges every day. So one of the things that I'm looking for is a specification that would allow me to capture the metrics necessary to quantify risk prevention. And I know this is hard.
Yeah, that's why I'm pausing, because I'm thinking, I don't think we're going to answer it on this call, but
No, we're not. We're not.
One of the things I was thinking about that I put initially, but then for the purpose of this, I removed it, was having a mitigation plan for every risk. And the risks and the mitigation plan would consist of controls. Now, what I'm thinking, and again, as I said, this is not something we're going to answer in this call, but one of the thoughts could be, if we give every control a control efficiency, then basically we get a quantifiable risk reduction from each control. So let's say that we suggest as part of because you can have 10 controls, but you might not implement all 10 of them. You might implement 2 that are most efficient and forget about the rest. Like, in terms of authentication, you might keep, some companies decide to keep their 8-character password or 6-character password and then implement MFA, because that's kind of the strategy that a certain company wants to take. So one of the things that could be done is to have, you list controls under the threats, but then when you come to risks, you link a mitigation plan, which is basically the chosen controls to mitigate these risks. And each one of these controls have their efficiency. So and the efficiency is, like you said, 0 to 1, and which is the percentage of how much a control reduces the risk. We could even be super granular and say likelihood efficiency, impact efficiency, to see what it specifically is, even though I'm not allowed to say likelihood anymore, but it's a joke. Or we could just say control efficiency to keep it simple. And then you have your percentage of how much a control reduces the risk. And then that way you kind of say, well, if you, implement the outcome of this threat model, you're reducing your risk by that much.
Yep.
So
yeah, and
this was already attempted. IEEE, Christoph Fischer was a working group I was involved in about 15 years ago. It's for 11073 standard that we're working at the end of the IEEE. We're doing exactly that. Every control had a metric associated with it for reduction. He finally published the paper long after I had stopped working on the working group. I don't know how effective it is, but I know if you're really interested, I can probably reach out to him and find out some more stuff.
or if you got a link, if they published it, but
Um,
if not, maybe, yeah, if we can talk
Yeah,
to
I'll
them.
see if I can reach out to him.
But a common one used is control efficiency. I've noticed it in some risk frameworks. So
Yeah.
we can start with that and then see what they came up with as well and potentially add more.
I have a question. Is there any kind of crossover between sort of threat modeling and what has been a part and parcel of my original career, which was chemical engineering, and that is hazard and operability studies, or HAZOP?
What?
I mean, you know, if that's if you've never heard of the term, maybe it's something
Yeah.
for you to have a look at out of the scope of the meeting. But this was something that I used to have to do in assessing risks. And, you know, if you think of a service, well, a service is technically like a tank on a chemical plant. It's got inputs and outputs. And in the physical world, you know, you look at every single input, every single output, you know, and you have to look at the sort of the assess for risks connected with everything from high temperature, low temperature, vibration, et cetera, et cetera, et cetera. But I know that HAZOP has actually been translated into the IT world. I'm just sort of wondering if it actually crosses over with threat modeling, because one of the things with HAZOP also is that you can actually get it wrong by applying it at the wrong time. Like if you apply it too late, you can actually be too late to do anything about it. If you do it too early, you're really just basically reviewing your design, and then you have to actually start doing the assessments again later on. So just like questions of something to think about.
Yeah, I mean, I think you can definitely say that hazard equals threat, like in a way, like it translates into threat, right? Like in that sense. So yeah.
Yeah, I just found a PowerPoint on HAZOP that I was just looking at. Yeah, it's interesting. I mean, it's basically the same questions though. I mean, what could go wrong? If you look at Adam Shostak's, you know, 4-method approach, you know, that's basically, it seems like what it is. But in a in you know, tightly scoped to the physical world.
Yeah.
Yeah. So no, this
So
makes a lot of sense.
35 years ago, that was basically what I was doing every single week.
Yeah, and OT is kind of a weird thing because it's the combination of IT on like factory floors and you know these types of things. So it's kind of like the marriage of physical and IT type of environments.
Well, on that note, I have to drop. There's a dependency
too.
community meeting, which is just starting.
Yeah. Well, this was a good call. So Christopher, Mark, if you want to review this schema, provide some input, maybe to Petra directly. But I'm really interested, Chris, in your opinion, especially on the data perspective, but on, you know, just in general, because I think it's going to help CycloneDX a lot. And I think as you know, Petra's spec, it'll likely help her a lot as well. But no, thank you, everyone. This was a great call. Look forward to chatting next time.
Yeah,
Cool.
this is really good.
Cheers.
Bye-bye.
Bye, everybody.
Thank you, everyone. Bye.